Some exciting developments in the world of science. Scientists have built a custom chromosome, a package of genetic material assembled entirely from synthetic DNA. Now, this engineered chromosome we're talking about belongs to yeast, but experts are saying that it can help them understand how genes work in us, humans, as well.
Well, and it could help make these tiny living factories better at producing everything from medicines to biofuels. VOA's Steve Baragona brought us this story, and he talks with me about the science behind it. We begin with the start of his report.
In a lab at Johns Hopkins University, students are stitching together machine-made strands of DNA, the chemical that carries the genetic blueprints of life. Their goal is to assemble all 6,000 genes in the genome of yeast.
Steve Baragona, what is yeast?
All right, yeast is a tiny little creature that it turns barley into beer, it turns grapes into wine, it makes your bread rise, and it's also used as kind of a living factory. Like for the biotech industry, they use it to produce chemicals, they use it to produce things like the active ingredient in anti-malarial drugs and to produce proteins in hepatitis vaccines and things like that. So it does a lot of different things.
And with genetic engineering, scientists could help yeast do those jobs better. Plus, these one-celled creatures share about 1/3 of their genes with us. Studying their genes can teach us a lot about ourselves.
All right, so yeast genes have a similarity to human genes. How so?
Yeah, I mean, basically genes are very similar across all living things, really. I mean, genetically, we are about 98% chimpanzee. And as it turns out, about 1/3 of yeast genes are similar to genes that we have. So they're doing jobs in the cells that need to be done in all cells. They're the same in whether you're a microscopic organism or a person.
So the students at Johns Hopkins are trying to duplicate this yeast chromosome. How are they doing this, and why are they doing it?
It's like it's a stitching operation, basically.
Okay.
You take a little chunk of DNA. DNA is what all our genes are made of. You lay another little piece on top of it, and you'll lay another piece on top of that, and you'll lay another piece on top of that, and eventually, and these things are big. I mean, a chromosome is like the one chromosome that they've done contains about 100 genes, and it's big. I mean, this is a lot of DNA, so it takes a lot of time. It's not difficult from a molecular biological perspective, but it's labor intensive. So it took a long time.
And so they've got 15 more, if you will, books to put together here.
Exactly.
And then what?
What they're doing in this case is they're designing it in such a way that they can take these chromosomes apart and put them back together and see how they work. And they're thinking that if they, once you can engineer these things however you want them, then you can design them to do those jobs that we talked about before, making bread or beer or fuel or chemicals, pharmaceuticals, drugs, vaccines. You can design them to do those things better. It's just all a matter of how you put those genes together.
Okay, and so something like this has been done before, as you just mentioned in your report. Mm-hmm. So what's different between what happened in 2008 and what the students are doing now?
The previous job was done in bacteria, and what's different is it's just a much simpler organism. These yeast are much more like us than bacteria are. So it's more relevant that they've done it in yeast than doing it in bacteria.
And in this lab, these are students. They're pretty young kids, if you will. And so, what do they say to you about doing this kind of research?
It's pretty cool. I mean, I used to work in research labs, and this was not something that we could do when I was a student. I mean, this is all things that have happened in the last 5-10 years or so, that you're able to do this at the level of undergraduate students.
Macintosh Cornwell says it's helped him prepare for a career in science.
The range of skills you learn and the amount of experience you get in such a small time frame it's invaluable, really.
But it's exciting for them. It's one of the things that kind of struck me from talking to these kids in the lab was not so much, wow, how cool is it that I'm putting together a yeast chromosome? For them, it's almost like, well, of course we can do this. It's biotechnology has progressed to the point where these are not difficult techniques. What's interesting to them is that these are the techniques that are going to prepare them for jobs, working in labs or doing any kind of basic research. These are like the fundamental skills that anybody going into this field has to know. It's almost like trade school for them.
So looking down the road 10 years from now, what is their vision? Where do they see this going?
What they're doing is they're engineering the instruction book for living things.
Okay.
If you can engineer the instruction book for a living thing, you can do almost anything. Yeah, you can make better fuels, you can make better medicines, you can make better, plants that'll help feed
better
the world.
People.
Better people. Could be, yes, yeah. That would be nice.
All right.